In this video, we're going to look at solving equations that have square roots in them. Now, if you take this first example here, the square root of x equals 5. If we remember that when we're solving an equation, all we're trying to do is find a value that you can put in for x that makes the equation true, then we might be able to figure out what x should be just by looking at it, right? So what number, if you took its square root, would give you 5? Well, that'd be 25, right? Of course, most equations are not going to be quite as easy to just spot the solution. For example, the next one here. So we need a more systematic approach. Okay. Now, in some previous videos, we looked at this idea that if let's take the square root of 9, for example, and I was to square it, that that just turns into 9. In other words, the square and the square root kind of zap each other, for lack of better phrasing. And of course, the reason for that is that the square root of 9 is 3, right? And that's because 3 times 3 is 9. And that's exactly what I'm having us do here is take 3 times 3. So the square and square root can eliminate each other. And so kind of the more systematic approach here would be to say, let's go ahead and square both sides of the equation. On the left side, you're just left with x, and then of course on the right side, you square 5 and you get 25. So that's how we're going to start these problems in general is if we've got the square root isolated on one side, then I can square both sides of the equation. And in a problem like this, it works pretty much the same way. It's just that if the stuff inside of the square root is a little more complicated, then we'll just still have a little bit of work to do after the square and the square root essentially eliminate each other. Let's go ahead and add 2 to both sides, and then divide by 3 on both sides. And so we get x is equal to 9. All right. Here's another example. And in this example, we um, have the square root of 6x minus 5 minus x equals 0. Now, in both of the previous examples, we were able to immediately square both sides of our equation, and that worked out great. However, let's understand that, and let me write something down here that I want you to not write. So do not take notes on this next little piece that I do here. If I were to square both sides, then we have to understand that if I was to square this, I would have to FOIL out this in order to figure out what the square is. And if I did FOIL it out, again, don't write this down because it's a pain. But if I did FOIL it out, I would have to go first, outside, inside, last, right? And I just made a much bigger mess than what I started with. All right. So this would be the consequence of squaring both sides before making sure that the square root is all by itself. So let's get rid of all this, okay? And we can avoid all that complication if we just take the first step. And here's where you can start writing again. Just take the first step of adding x to both sides. So now, if I then square both sides of this equation, then the square and the square root just eliminate each other. And we have this. But this is a quadratic equation, and we know how to solve it, right? We want to get the terms on one side and 0 on the other. So we'll have 0 equals x squared minus 6x plus 5. And then let's see, this factors into x minus 1 times x minus 5. So that gives us two separate equations here. X minus 1 equals 0. X minus 5 equals 0. And so kind of ran out of space on my slide there. We end up with x equals 1 and x equals 5. Now, the examples that we did prior to this one were both, pretty straightforward. This one has more variables involved. There were more steps. We had to solve a quadratic equation at the end of it. So I think it would be good to check our work here. All right, so let's check. And by checking, we mean go to the original. I'm going to do this in a different color, though. But we're going to go to the original equation before we even move the x to the other side, right? Before we did any of that. And let's do green here. So the square root of 6 times 1 minus 5 minus 1. So just plugging 1 in where I see an x, and I'm asking, is that equal to 0? All right, well, square root of 6 minus 5 minus 1. Well, sure, 1 minus 1 definitely equals 0. So that one checks out. If I do the same thing with x equals 5, the square root of 6 times 5 minus 5 minus 5, does that equal 0? So that's 30 minus 5 under the root. 30 minus 5 is 25, so this would be 5 minus 5. Yes, that equals 0, so this is also a solution. So we end up with two solutions here. Okay. So our steps to solving an equation that has square roots in it, or a radical equation, is number one, isolate the radical. We had to do that in the last problem, right? So first step was to add x to the other side, so the square root was by itself on the left. Then raise each side of the equation to the power equal to the index of the radical. Okay, so these instructions are for solving a radical equation in general, which would include cube roots and fourth roots and so on. But for the specific ones that we're going to restrict ourselves to, we can just replace this with to the second power, because we're just going to focus on square root equations here. Number 3, we'll solve for x, however you need to do that. Sometimes it's solving a simple equation. Sometimes, like the last one, we have to solve a quadratic equation. And then number 4, that last thing we did was we checked potential solutions. Okay, checked potential solutions. So looking at this next example, we can see that the radical is not by itself on the left side. So we want to start this by subtracting 3 from both sides. Okay. Now I want us just to stop for a moment and look at what this is saying. This is saying the square root of 4x plus 1 is equal to negative 3. Can we ever have a square root equaling a negative number? Well, no, we can't, right? A square root is always going to give us a positive number. So what that means is that there is no x that could make this equation true. And so I would just immediately say that there is no solution to this equation. Okay, no solution. Now, let's suppose we're just kind of going through and just, working through these problems quickly and you just didn't notice. Okay, so you ever see square root equals a negative, you can immediately go to no solution. Okay, but suppose you didn't notice and you went ahead and squared both sides. then that would give you 4x plus 1 on the left, 9 on the right. You get 4x is equal to 8. X is equal to 2. Okay, so now it looks like I have a solution, right? So this is where checking your work is so important, right? This is why we need to check, is because if I do check on x equals 2, square root of 4 times 2 plus 1 plus 3, does that equal 0? Well, no, it doesn't, right? That does not equal 0. So since when we check it, it doesn't work, that means that this is not a solution. Okay. And then, so even if you went through the process, you could come back to this idea of, okay, no x is going to make this equation true. But like I said, no need to do any of this if you notice you have the square root is equal to a negative. Right, now let's look at one more example. In this one, I'm lucky enough to have the square root by itself right away. So I can square both sides, leaving me with just 9 plus x. And then on the right side, be really careful here. You have a binomial squared, right? So you have to write this out as x plus 3 times x plus 3. So foiling that out gives x squared plus 3x plus 3x plus 9. So x squared plus 6x plus 9. And then let's get one side equal to 0 since this is a quadratic equation. And of course, here we have some factoring. I can pull an x out of both terms. So I have x times x plus 5. So on the one hand, we get x equals 0. And on the other hand, x plus 5 equals 0. So we get x equals negative 5. Right? Now, notice where we're at up at the very top. In the previous problem, we could see when we had trouble, when we had the square root equal to negative number. Okay. Here, I can't tell whether the number on the right is positive or negative because of the fact that it's a variable, right? So it kind of depends on what x is. So this is once again where it's vital to check. So we'll check x equals 0 first. So if I plug in 0 for x, do I get a true statement? Well, yes, I do. So that means x equals 0 is definitely a solution. So let's check x equals negative 5. So square root of 9 plus negative 5, does that equal negative 5 plus 3? Well, I'm going to get a square root of 4 equals negative 2. Well, that does not work, right? Square root of 4 does not equal negative 2. So that means that the negative 5 is not a solution. It's an extraneous solution. We saw this kind of thing happening when we worked with rational equations, when we had these candidates as solutions that ended up making us divide by 0. Well, here we're getting this candidate of x equals negative 5, but it's making it so that the left side doesn't actually equal the right side. Okay, so that's gone. And so just one single solution here. So that can happen. So sometimes there's just no solution at all, like in this example. Other times you might get more than one candidate and only one of the solutions or only one of the candidates is actually a solution. Or if I go way back to this example, we got two different candidates and they both worked. They were both solutions. I'll just make a quick comment here of what is occurring. The idea is why is -5 being kicked out? Well, if you plug -5 in right here, then this whole thing becomes -2. And so then that would be the exact same scenario we were facing here when we had the square root is equal to -3. The difference is because we didn't know what x was at the beginning, we weren't sure if that was happening or not. Okay. So that's why uh, that one doesn't work. And furthermore, why is it that it ends up giving a fake solution? In other words, why are we tricked by it? Well, the reason is because if you take something like, right, the square root of 9 plus x and set it equal to putting a -5 in there, and so set it equal to this, and you square both sides, well, if you plug a -5 in, that's the square root of 4, -2, and then if you square both sides, it makes everything okay, doesn't it? Right? So squaring each side of your equation loses that information about one side being a square root and then the other side being a negative. So that's why how we kind of get fooled into thinking that maybe x equals -5 is a solution. So just to really drive this point home, this last step, if you have variables on one side of the equation, then uh, after you've gotten the square root by itself, so you have the square root by itself, and then there's variables on the other side, make sure you are checking your solutions because you might get extraneous solutions, meaning numbers that come out as looking like they're going to be solutions, but actually are not.